Okay, welcome everyone. This is the spreadsheet that you have to do for your first CML lab exercise in the soils topic. And we're putting this little demo video together so that you can get up and running with the spreadsheet as quickly as possible and not waste your time playing around with Excel or figuring out how to do things in Excel, but instead spend more of your time actually learning about the interrelationship between water content, metric potential, total potential, and gravitational potential. So to begin with, you probably want to have a bit of an idea of exactly what it is that we're doing here. And this little model, you can think of this whole spreadsheet as a little model, is actually of a column of soil that is 1 meter in length, right? So that represents the depths of our soil column. And we filled it with a soil type number 2. The number refers to these soils across the top here, and number 2 is a sandy loam. Number 1 is a sand, 3 a loam, 4 sandy clay loam, and 5 a sandy clay. Right? And how we're going to differentiate between these soils is by using these parameters here, which are called our Van Genuchten parameters. And these parameters are taken straight out of the modeling program Hydrus. And what they actually do is they form part of a function which will determine, or you can use to work out, the water contents. So these parameters are going to give these values over here, right? Or these thetas over here, like these theta values are going to produce this graph right here. It's also going to change our K values there. You don't need to worry about what those formulas are. All of that stuff's filled in for you. But to get you up and running with the spreadsheet as quickly as possible, the first thing the question sheet is asking you to do is to add the missing lookup functions. Right? So Dr. John Hudson, the guy who created the spreadsheet to begin with as an exercise, has put the first lookup function in for you so you can get some idea of what it's supposed to do or how it works. Right? So if you click in the formula bar over here, right, the cells that the lookup function are targeting will be highlighted. So what you end up with is a function that is looking at this cell here, D22, for a value. It's taking that value and trying to locate it within this range of cells here from D6 to H6. If it finds the value, it's going to relate whatever column that is to this range of cells here. So it finds value number 2 in this column. Then it's saying pick out the value that corresponds to that column in this range. Right? So from D16 to H16, the value is 1564. Right? So if we just hit enter before you click anywhere else, otherwise you could mess up the formula. Right? So 1564 corresponds to that. That's exactly what we want. If you want to now copy that function down the rest of the column, you can click in that corner and drag down, or what you can actually do is just double click, and that'll fill it straight away to the bottom for you. If you look at the second one, right, you can see we're targeting this cell now, D23, not D22 as we were before. But we're still targeting the correct range of cells here and here, right? Same if you head down to the next cell, you'll see the same thing, but you're looking at D24 now, but you're still targeting these. So that's going to give you a clue as to actually what you need to do for the next column, where you also need to insert a lookup function, right? So the only thing that actually needs to change is this value here, right? D20 something. So if we need to copy a function to here, or create a lookup function to give us the theta r value, then all we need to do is ensure that instead of targeting bulk density here, we need to target theta r across there. That's really it. Now, the issue you get when you try and just copy and paste the function across is that all the target cells will be shifted across as well. So to avoid that, what we want to do is we want to fix the function before we copy it. Fix the target cells that the function addresses before we actually copy the function. Right, so make sure you don't have anything highlighted. Click in the first cell of bulk density, right? We know that D22 up here needs to change, so we can't fix anything there. Or you could, because it's always going to be D, right? So we don't want D to change. So what you want to do is enter a $sign in front of D, right? So when we copy this function across to the next cell, it's still always going to look at D. When we move down, we know that 23 is going to change to 24, so we can't fix 22, right? 22 has to be able to change. These ranges have to remain identical. So what you could do is just pop $signs in front of D, a $sign in front of H, another $sign in front of the D over there, and another $sign in front of the H over there. If you're interested, you can actually use a shortcut where you highlight both values and you hit the button F4, right? It will usually put in $signs for you, but in this case it's not for some silly reason. Anyway, you just want to make sure that all those values are fixed and that they're not changing at all. So there has to be a $sign in front of each letter and each number in the green and purple target cells. Okay? And we only want a $sign in front of the D for the blue target. And that's it. Hit enter. Now, if we copy and paste function only or formula only to the next cell, right, what we should see is that those values have stayed the same. D hasn't shifted, but we're still targeting bulk density. Now, we don't want to target bulk density. We actually want to target theta R. So to target theta R, we need to change the purple values from 16, which is the row here, 16, to 10, which is that row over there. So all the '16s need to be changed to 10s, right? And that's pretty much it. Now we've got 0.065, which should correspond to the theta R value of soil number 2, and that's correct. So we put our little cursor on the bottom small square, double click, and it should fill in the rest of the values for us. To check whether it's working correctly, you can just change that to 1, and these values here should change to the parameters theta R and bulk density of number 1. Right? Change it to 3, and yep, we should get the same values for 3. Change it to 4. Yep, 4 is the same. So leave it back at 2 for now, just so we're sticking with the same thing throughout. Now we need to do the same thing, copy the function, paste formula only. And in this case, we want alpha. So alpha is 1 down, so all we need to do is change that 10, the purple 10s, to 11s. And if you click in the formula bar now, you can see we're targeting the range of alpha values. Put your cursor on the bottom small square and double click. That'll fill in the rest for you. Copy the function across, function only. And now we want to target the values for n, which just means that these 11s need to be 12s. Okay. Click in that bottom little square, or get your cursor on that bottom square and double click. And you can see something happened here now. This has gone all to 0. Before we had no value at all. So a few things have changed. Once we fill in this entire table, we should start to see other values over here. Okay, so we're going to copy this function across again, paste that function there, We want to target the KSAT values, which just means that this one needs to be changed to 13. That one needs to be changed to 13. Enter. Double click on the small square. That'll fill up the whole column for you. Okay. Copy it across. Paste the function. Right. We need to target M. So this needs to be changed to 14. Oops. Double click. Off we go. Copy again across. Paste the function. We need to target 15. There we go. So now you can see we've got K values appearing here, and we also have theta values appearing here now that this table is completely filled. Right, so that's step one done. We've added all the lookup functions, and if you want to check that it's working properly, just change the values in the soil. Double click the column and make sure that all these values match the values for soil type number 1. And check the rest just to be sure so that you're not making any mistakes. Go through with 3, 4, and 5. Oops. Okay. That all looks good. So let's set it back to number 1 for now. Okay, the next part. Insert the necessary equations into cells N22 to N61. Right, so we're referring to the matrix potential equation, which if you scroll down, what the hell is this? Okay, forget that. If we scroll down, it is this function over here. Right, that's the one we need to enter. And first thing you need to know is that hj minus 1 corresponds to this cell over here, N22. So that's N22. The negative Q, or the Q itself, is actually whatever's in this cell over here at 05. Delta Z is 0 minus negative 25. So M22 minus M23. K is actually, let's have a look here, this K over here, right? So this is your K, and let's bring that sheet back. Hj is the value below Hj minus 1. So this one here, N22, was Hj minus 1. N23 is Hj. And of course, delta Z is the same as the delta Z over here. Alright? So, let's do that. So first we have Hj minus 1, which is our target cell here. Push equals, right, to say that this cell is equal to negative Q. This is our Q. And we don't want that Q to change, or we're going to change it ourselves manually, but we don't want the target cell to change. So highlight both values with your cursor and then hit F4. It should work for some people, maybe not for everyone. For some reason it's not working for me right now. That's okay. So we'll just put dollar signs in front and back of 0 and 5. Right? So negative Q. And then the next part of the equation is multiplied by delta Z divided by K. Okay, so in Excel, multiply is a little star, multiplied by delta Z is going to be this value minus this value. Alright, and then divide, so we want a backslash and K. Now, this is tricky. It has to be the second K not the first K. If you click the first K, it'll stuff up. Right? So it's that K over there, R23. Right? And then let's have a look at the rest of the function. Plus hj minus delta z. Right? So what we want here is plus hj, which is that one over there, minus, open bracket again, and then we want m22, whoops, m22 minus m23, close bracket. Right? And that's all you need to enter, and that should work for you fine. Okay, once we have that function, right, a value will appear there. You'll see a little change here in the top corner in the water content column as well. That will change. You'll notice that this value down the bottom here, at the bottom of the column, has been filled in for you already, and it has a different function to the one that you entered in at the top. Make sure when you fill in the rest of the column that you don't copy over that function. Okay? If you do, you get completely weird answers or results. So what you could do is, just to be safe, copy that one and paste it there. Right? Just do that, just to make sure it's there. If you inadvertently copy over this, then at least you'll still have it there. So if we double click that, it'll drop everything to there, but notice how it stops short of that function there. Whereas if you dragged, right, so if you did this and dragged down like that, and you went over that value, you would actually change the function. But the double click will stop before you actually hit that 0 value over there. Right? So just check that that function is still the same as what it was before. It should be completely different to the function that's over there, which is the one you created yourself and copied down. Okay, that's excellent. We're almost done. The only other thing you need to be aware of now is that total potential is the same as the gravitational potential plus the matrix potential together. Right? So we want the answer in millimeters, so all that means is you've got to add these two columns together. Right? So hit equals, and then click this one, put a plus sign in, and then that one, and then enter, and that'll give you the value. Right? And then just again double click in the corner, and that should fill everything for you. Once you've done that, you should have graphs that appear like this. And this is pretty much it as far as getting the spreadsheet up and running. Okay, so I'm going to end the video now because I don't think you actually need anything more than that. I might post another video later talking about changing the values and what it all means. Okay, thank you.